Again, I got myself a new video recording software, open source of course, called OBS Studio, and I thought I'd test it with a small project. I have a designer lamp for which I used a halogen lamp, and because of the intense heat it creates, the base actually degraded over the years to the point that I have to replace it. So I went to a electronics store and I got myself a new lamp base, and then I 3D printed a container for it, if you like, and I thought I'd show you just how I did it. Of course, when you start doing something like this, you have to have the measurements, and in my case the measurements were 2 centimeters across and 3 centimeters tall, and it has to have a cavity of certain proportions. So I'll show you how I made that replacement part. So as always, when you open Blender, this is your basic view where you have the lamp, you have, oh sorry, camera, and you have the lamp, and you have the default cube. I don't need the default cube for anything. I'll just delete it, and then I will add a cylinder instead. Now I need more vertices than 32, because when you print something, it can actually print circular things so that the 32 vertices will show. I'll just add 60 so that it looks more round. At this point I'll also go into edit mode, select the bottom of the piece, snap the cursor to it, go out of edit mode, set the origin to 3D cursor. Now the base of the object is, or the origin of the object is here. So when I snap the cursor to center and then snap the selection to cursor, I know that the base of the cylinder is on the print table. This is absolutely vital. If it is like so, it will not print because it doesn't have any connection with the print table. So always remember to set the origin at the base at this point. Otherwise you will have a problem later. Now this piece needs to be 2 by 2 by 3 centimeters. So I will do it like so, and then I will rename it the lamp base. It's much easier to remember what you're doing if you have many pieces and you have named them all. So what you need to do next is to create another cylinder that you will be using as a drill. To do that, all you need to do is to go into the place where you want the thing to appear. So go into edit mode and Shift S and select cursor to selected. This is the place where you want it to appear. And Shift A and add a cylinder. It will remember the 60 vertices that you set up in the previous one, and then when you reset the size to 1.7, 1.7 and 2 centimeters, you will see that it's actually quite neat, because when you look at it from the side, you will see that you will have the 1 centimeter of depth that you wanted to have in the first place. Now for printing purposes, I think it always makes sense to make the drill just a little bit larger than the hole that you want to have. So I'll make it 1.72, 1.72, and I will move it down like 1 millimeter more, like so. So I will call this cylinder the drill. Go back into the top or the user ortho view, and then a very important step in drilling is using the apply command. You need to apply location, apply rotation, and apply scale for both of the pieces before you try to use the booleans. If you don't, it might work, but if you do, it will work definitely. Then select the big one, add modifier boolean, operation is difference, object to use is the drill, and when you apply, you will see that you will have a nice dent in your piece. The next thing I want to do is to use the same drill for a hole that is 1.5 centimeters across, then 1.5 centimeters the other way, and the length of the piece doesn't matter at this point. Just snap it back to the bigger one, selection to cursor, and then pull down so that you are left with a bottom down here, but from the top you will have a shelf around the piece. Now again, I strongly suggest that you Control A, the location, rotation and scale. And now select the big one, add modifier and boolean with the difference with the drill and apply, and you will have a cavity and a shelf, another cavity, and all you need now is a hole at the bottom of the piece. So I will snap the cursor to the selection, then I will snap the drill to the cursor, pull it down and scale it down so that it's like 0.4 times 0.4 centimeters. At this point it doesn't really matter where you place your drill. All that matters is that it goes through the base and has been applied. So apply location, rotation and scale. Select the big one, add boolean with the difference with the drill and apply, and now you can delete the drill because you don't need it anymore. So you have a nice piece for printing. This is for the lamp base, this is for the wiring, and this is for the wiring to exit at the bottom. And now we can move on to the actual printing part of the thing. When you're doing printing, you can scale your stuff on the Repetier host, which is the burning software, or you can do it here in Blender. I usually scale my stuff up by 10 in Blender so that I don't have to use the scaling in Repetier host, but that's just me. You're free to do it any which way you like. Now, the reason I use booleans is that when you go into 3D printing and you press check all, you will see that you don't have any non-manifold edges. Your piece is perfect for printing because it doesn't have any problems with being manifold. So now that it is selected, you just go into File, Export, STL, go into the place where you want to have it, and call it lamp base STL. So when you go into Repetier host and click on object placement, lamp base STL, you will see that it is of the nice and even perfect proportions, 30 millimeters by, I don't know why you don't see the dialog boxes, but anyway, here we go. So when you slice it up, I'm using basic 20% infill with 0.3 millimeter layers. I'm using the mini factory printer this time, and I'm using basic ABS. I hit the slice with slicer button, and I am looking at 11 minutes of printing time, 100 layers, of course, because the layer height is 0.3 millimeters and this is a 3 centimeter piece. I'm using 1.4 meters of wire, and the print is going to look like this. When I go in here and I use show layer range, I can go layer by layer and see how the print is going to be built. Here is where it's going to switch into the final container. So, and it has the hole in the bottom. So and then all you have to do is go and connect your printer and then hit print, and 11 minutes later you will have your piece. So that's how you make a replacement for a designer lamp. I personally think that they should buy higher quality lamp bases if the lamp costs you that much money. But there's nothing you can do except print a replacement if you need it. So thanks for watching.